Greetings of the day. Today I am going to talk about current transformers. What is the definition of the current transformer? How it works? And what are the different testing methods and type test of current transformer? So first of all, we understand what is current transformer. Current transformer is basically purpose of current transformer is protection and measurement. And protection, we can say in protection system, current transformer plays very important role. Further, for the protection type current transformer, there are different types of current transformers available, like class PS type of transformer, that is special protection class current transformers used for the special protection like bus differential, REF, transformer differentials. These critical protection is covered by the special protection type PS class transformer. Class 1 category is generally used for the measurement purpose. So these are the transformer used for the measurement purpose. So basically current transformer is nothing what primary circuit and secondary circuit, each and every transformer has two circuits. So if we are talking about the current transformer, then primary is connected to the line. Here in the primary side only one or two number of turns, and secondary side number of turns are more. So we reduce the current in the secondary side so that it will be easy to measure, so that it will be easy to take readings or connect in circuits like relay and everything, so that we can read the value of current and can be used for the protection system like in relays and other metering devices. So this is the definition of current transformer. Now current transformer testing. So very important aspect testing is one of the current transformer is. First is the IR, that is insulation resistance. Insulation resistance basically tells about the healthiness of insulation between current transformer primary and between primary and secondary, between primary to earth, between secondary to earth. So as per the rating of voltage, current transformer insulation testing is done. So basically what we do and how we do this insulation testing of the current transformer, we inject DC voltage through the maker, primary to earth, then measure, suppose let us say if your current transformer is 415 volt for the LT system, then we can say we can do the measure up 250 volt, primary to earth, secondary to earth, and between primary to secondary. If measure value is more than 1 mega ohm, then ideally we can say the current transformer is okay. And what is the thumb rule of this value? So just we can assume on the nutshell we can say 2 into kV plus 1. So 2 into kV, suppose for 415 volt system, this 2 into kV, 2 into 0.4 plus 1. So 2 into 0.4 means 0.8 plus 1. So 1.8. 1.8 mega ohm is the minimum value for this mega, primary to secondary, secondary to earth, and primary to earth. This is the one of the very important test. Secondly, this binding resistance. In the binding resistance, we measure the resistance of secondary winding. So S1, S2 is the, suppose let us say single core current transformer, then there is S1 and S2. If two core transformer is there, so there will be four numbers of secondary winding, like 2S1, 2S2, 1S1, 1S2 terminals, four terminals, correct, and two winding. So we measure the resistance between 1S1, 1S2, 2S1, 2S2, so it gives the value, and we can record these values for the future reference. If suppose there is a problem in system, we can capture it. Then third test is the ratio test. That is the basically we inject the current in the primary and measure in the secondary. So this ratio test gives the Turner ratio value. And last test is knee point voltage test. So how we perform this test? Knee point voltage is very important, especially for the PS class CDs. In the secondary side, we inject the voltage and also measure the current of the secondary circuit. So initially, this value of voltage and current records in a graph. We can plot the graph between excitation current and secondary voltage. So initially, this value will be linear. Voltage and current will be increased linearly. But when it reaches the non-linear graph, means 10% increase in the excitation current. If suppose 10% increase in the excitation voltage, suppose there is a variation of 50% in excitation current. In this particular moment or point, we can say this is the knee point voltage of the current transformer. So these are the very important aspects of the current transformers. I hope you understand. Thank you for watching.